Okay, so here we can see again we can just focus on the transformations and work out the domains that way. So for the x, I know I've shifted it. I have a horizontal translation. So my change in x is going to be it's going to go to the right. It's going to go plus 9. Okay, so that's where my vertex is going to end up. It's going to be at 9, so my domain, and there's no horizontal flip, so I know that it's going to go to the right. So the domain is going to be from 9 and to the right. For the y, I can see that it's been flipped upside down. It's kind of hard to see because the y transformation is kind of on the wrong side here. So the first thing I'm going to do before I do the y is I'm going to make it equal to y. So to do this, I'm going to first minus 3 and then divide by negative 2. Okay, so I see a horizontal compression and a flip. Now I want to know where the vertex is, so I'm going to simplify that expression here. And I don't know if I have enough room here, but I'm going to make this into square root x minus 9. So that's going to be negative 1/2, so that gives me the direction and the flip. And then the vertex is going to be at 3 over 2. So that's the point I'm going to use as my reference. My vertex is at 3 over 2, and I've been flipped upside down, so I want the negative side of that. I'm going down. So my transformation, I'm going to express it in this case, in this form here. I'm going to do the flip and then the shift last. So here it's going to go as a vertical flip. Okay, it's a vertical compression by 1/2. This compression doesn't actually affect the range of this function. And then lastly, it's going to be a vertical shift plus 1.5. Okay, so the flip will affect our range. The shift will affect the range, but the compression actually doesn't affect our range, especially since it's done before the shift. So this one here, we can do our horizontal transformations. Okay, I'm going to do the horizontal first. So with my horizontal transformation, I can undo all that notation. So my change in x, okay, so my change in x is going to look like this. My notation is going to be negative 2x minus 5 plus 1. Okay, I'm actually going to simplify this first. So let's simplify this first so that I can work this out. I'm going to end up going negative 2x plus 5 plus 1. Okay, so then I'm going to end up with plus 6. Okay, so that's my notation still. I'm going to solve for the other x. So this is now the actual transformation described the way the order in which I would do it. So I'm going to go 6 to the left and then divide by negative 2. So I know I'm going to the left because of that flip. And my vertex is going to be 6 to the left and divide by negative 2 is going to be 3 to the right. So I know that my boundary is x equals 3, and I want the left side the negative side because I've flipped this around, okay, because of that horizontal flip right there. Okay, so just describing that transformation is going to be, actually I'm going to do this, I like to do the flip first. Because that way we can actually see, if I separate that out, we can actually see the vertex position here, right, when we do the shift last. So the first thing I'm going to do is a horizontal compression by 1/2, horizontal flip, okay, and lastly is my horizontal shift plus 3, and that helps me identify my vertex. Vertical transformations, well, the vertical transformations actually are all in reverse because the transformations are all with the y. So what I'm going to do is I'm going to undo that transformation here. So change in y is going to be 5 plus 2y over 3. And this is actually my new y here. And the square root, I'm just going to write it as my old y because this really what it is. The square root is actually the original y the y function. So what I'm going to do is undo all this. So I'm going to end up getting 2y is equal to 3y minus 5. Okay, I'm going to times by 3, subtract the 5. I'm going to divide by 2. And I'm going to divide by 2 these two parts separately so I can see the shift separate from the compression. So my steps here are going to be, I've got a vertical compression, or that's an expansion, isn't it? Vertical expansion by 1.5. Okay, it's a vertical shift minus 5 over 2, so my boundary is going to be 5 over 2, and I know I haven't flipped this, so I'm going up from here, so that's going to be my y domain, or sorry, my y range.